Okay, so now a little bit, going back and reviewing a little bit about inverse trig functions. We're going to do more on this later. I just wanted to kind of go over the differences. So on your calculator, you'll notice that there's something that says f to the negative 1. That's not the same thing as 1 over the function. Be careful of that for this. Not for inverse functions. So you have to be careful of that. So an inverse, so f of x is your original. F to the negative 1 is the inverse. So for example, if I have sine of theta equals x, and I'm trying to solve for theta, okay? We did compositions earlier in the year. If I raise it to its inverse, then that means the sine to the negative 1 and the sine will go away, and I'm left with theta equals sine to the negative 1 of x. So when you find an inverse, it means instead of me giving you an angle and a side and you finding a missing side, I'm giving you two sides and you're going backwards to find the missing angle. So example 5, theta, 15, 12. I want to find theta. So from the theta, this is my 12 is my opposite side, the 15 is my adjacent side, and opposite over adjacent is tangent. So tangent of theta is opposite over adjacent. So if I want to find theta, I need to take the inverse of both sides. So on your calculator, you need to do second tan. That's how you go backwards and find the angle of 12 over 15, and you're going to get that your theta is about 38.7 degrees for that problem. We're also going to talk about some word problems. So just in general, if I give you, say, for example, a person, and there's a building, okay, so, and you're looking up to the top of the building, okay, this angle down here, this is your angle of elevation, that's your angle up to the building. And then, say for example, you're a plane up here, and this angle in here is your angle of depression. And if you remember from geometry, if you have two parallel lines, a line up top and a line down here, cut by transversal, these are alternate interiors. Your angle of depression should equal your angle of elevation. They also call this line here the line of sight. Okay, example 6. So a ski lift rises, I'm just going to read this to you, at an angle of 21 degrees. So here's my mountain. Don't make any fun of my drawings. This is a mountain. So I have a ski lift, rises at an angle of 21 degrees. It attains a vertical height, which is this height right here, of 1,200 feet when it reaches the top. I want to know how long is the cable for the ski lift. So I want to know what this height is here. So we're basically just going to set up a SOHCAHTOA problem. So from the 21, the 1,200 is my opposite side. The x is my hypotenuse. And so opposite over hypotenuse is sine. So sine of 21 degrees equals your opposite over your hypotenuse. And again, when your x is in the denominator, switch these two. 1,200 over sine of 21. And when you put that in the calculator, you get about 3348.5 feet. So then, if you were standing here, let's say at the bottom of the ski lift, and I were to ask you to find the length to the horizontal length to the mountain, you could do Pythagorean theorem, or you could do another trig function. Okay, so here's another one. My example 7. And I'm going to draw the picture on the first screen, and then I will do it again on the next one. So we have a building. So this is my building. Here's the front door. Here's my building. Don't make fun of my pictures. That's my building with my roof. My angle of elevation, so if I'm out here and I'm standing out here, my angle of elevation to the top of the building here is 48 degrees. If I move in 22 feet, my angle of elevation changes, and now that's 64 degrees. I want to know how tall the building is. So I'm also going to label this down here Y, because this is one way that we can do this. So I want you to take a minute and copy this down. On the next screen, because I can't fit this all in one screen, I'm going to write this as two separate triangles. I'm going to do the one with the 48 degree triangle, and then I'm going to do the one with the 64 degree triangle on the next screen. So if I separate these out into two triangles, I have 48 degrees down here, and I need my height. This length is 22 plus y. On the other triangle, that was 64 degrees and y, and my height was x. So if I set up trig functions for these, this is opposite over adjacent, opposite over adjacent. They're both going to be tangent. Tangent of 48 degrees is my opposite over my adjacent. My tangent of 64 is my opposite over my adjacent. Now, if we're trying to find x, you could solve for y, but this gets kind of messy. So I'm just going to solve for x right now, because I can look at this and easily get this x by itself, this one by itself, and then set them equal. So my x is going to be equal to, oops, let me erase this. If I multiply both sides by 22 plus y, 22 plus y, I'm going to get 22 plus y times tangent of 48 degrees equals my x. And then over here, we're going to get y times tangent of 64 equals x. And since both of these equal x, I can set them equal to each other. I'm going to have to do this on the next screen after I write it out. Equals y times tangent of 64. We're basically just solving a systems of equations. Since they're both equal to x, I can do substitution and set them equal. On the next screen, I will do the math for you. All right, from the previous slide, we had y plus 22 times tangent of 48 equals y tangent of 64. So if you move your y over to this side, your tangent over here, you get y plus 22 over y equals tangent of 64 over tangent of 48, which gives you y plus 22 over y equals 1.85 when you put it in the calculator. So if we multiply both sides by y, we end up with y plus 22 is 1.85y, which makes it 22 equals 0.85y. And when you divide by 0.85, you get y equals 25.9. Okay, so let me redraw from the previous screen. So the last part that we have, if we look at, we're ignoring this original one, we're looking at the one where the 64 degrees was in, we found that our y was 25.9, and then our x was over here, and so that is just tangent of 64 equals x over 25.9, opposite over adjacent. So our x equals 25.9 times tangent of 64, and if you stick that in the calculator, you get about 53.1 is the height of the building.